Hello you 12 and welcome to our second video here for networks. Now we're looking at the shortest path today. We did actually answer a couple of questions the other day in our previous exercise about that asked us to find the shortest path. And we're going to look at that in a bit more detail today. Now the shortest path is simply the path from one point to another, that uses the smallest combination of edges. And sometimes we can just find that by trial and error. That's what we did in exercise 801. So I want to get from A to F. There's A and there's F. I want to get there the shortest way. Now keep in mind, networks are not to scale. So, it's not necessarily what at first glance looks like the shortest path. So, to get from A, I could go to C in 4 units. Or I could go via B, and 1 plus 2 is 3 units. So even though that looks physically longer, it's not, because it's not to scale. So 1 plus 2, 3 is less than 4. So the shortest path to C is in 3 units. There's only one way to get to D from there, so that's another 5. Now from D, I could go via E to F, or directly to F. Now if I go via E, 6 and 3 is 9 more. If I go directly, it's just 8. So that's my shortest path. Okay, 1 plus 2 plus 5 plus 8, 16. Shortest path from A to F is the path A, B, C, D, F, and it has a length of 16. Righto, there is another way to find the shortest path. Okay, now there are some instructions written down here. Start by drawing the graph. Instead of dots at each vertex, put an open circle that you can write inside, big enough to write a number in. And then you find the distance from the start to the first set of vertices, and you write the shortest distance in that circle. Then you look one step further away from the start, but you don't have to go all the way back to the beginning. You just go back to those previous vertices that have the shortest paths written in them. So you don't have to keep going back to the beginning all the time, just back to the previous set of vertices. Keep going until you get to the end. This will make a lot more sense, I think, with an example. So here we go. We need to find the shortest path from A to E. The shortest path to B is up here, is 3, and to G is 4, straight down there. I guess I could go via C, but 7 and 2 in both cases is 9 and much longer. So now we want to find the shortest path to C. I could go via B, which would be 3 plus 2. I could go via G, which would be 4 plus 2, 6. Or I could go directly from A, which would be 7. And the shortest of those 3 is via B, is 5 units long. So we put a 5 in there. There are lots of different ways we can get to C, but the shortest way is 5. Now we're going to look at D and F. Now, to get to D, I could come from B, via B directly would be an extra 9, takes us to 12 units. I could come from C, which would be 5 plus 6, and 11. It's going to be our shortest. So 11 goes in that circle. Now for F, I could come from G or from C. 4 plus 3 is 7, 5 plus 3 is 8, and the 7 is the lower of those. So that's the shortest distance to F. Now we're close to the end. To get to E, I could come from D, C, or F. If I come from C, it's 5 plus 10 is 15. From D, 11 plus 4 is 15. But from F, 7 plus 7 is 14. So the shortest path from A to E is 14 units. And we can get there along this path, A, G, F, E. Rightio, I have another example here. You might want to pause the video here and have a go at doing it yourself. We start at A, and then to B, the shortest distance is 5. To G, the shortest distance is 4. Now, to get to C, I could go 4 plus 1, 5 plus 2, or 6. And I think that 4 plus 1, 5 is the best way. Now we need to look at D and F. Now it might be 5 plus 9 is 14, or 5 plus 6 is 11. So we need an 11 there in D. To get to F, 4 plus 3 is 7, 5 plus 3 is 8, so a 7 goes there at F. Now finally to E, 11 and 3 is 14, 5 and 8 is 13, 7 and 7 is 14, so via C is our shortest path. Okay, so A to G, then G to C, C to E. Our shortest path is AGCE, and it's 13 units long. Righto, that's it for the shortest path. Just a reminder, what we looked at here today. To find the shortest path, right, you start at the beginning and you just go one step forward. Find the shortest path to all the vertices that are one step away from the beginning. Then you find the shortest path from those vertices to the next ones that are 2 steps away from the beginning. Okay? So we don't have to go all the way back to the beginning, just back to the previous lot of vertices. Rightio, well if you have any questions, please ask me during class, or send me a message. Otherwise, our next video is going to be on maps and networks. Hope you enjoyed.